today we are learning about one of our new best friends. It's called the Pythagorean theorem. Okay? Pythagorean theorem only applies to right triangles. Okay? So you can only use the Pythagorean theorem with right triangles. Okay? And we're actually going to use it to find missing sides. So they are going to give us problems with only two of the sides, and we have to use the Pythagorean theorem to find the third side. So I wrote it out really big for you and then put it in a box. The Pythagorean theorem for a right triangle only. We take the leg and square it, plus the leg squared. So both legs, we square them and then we add them together, is equal to the hypotenuse squared. Okay, so leg squared plus leg squared is equal to hypotenuse squared. Okay, and we're going to use this to find missing sides. So, example number 1. We are going to use the Pythagorean theorem to find the missing side in each triangle. So, here is a right triangle. How do I know it's a right triangle? Good, because it has the 90-degree angle right here in the corner. Okay, can someone name one of the legs for me? 3 is one of them. Julian, what's the other one? 4, and what is my hypotenuse? X. We don't know what it is yet, so right now we're just going to call it X. So we don't know what it is yet. Right now we're just going to call it X. And what we're going to do here is we're going to plug everything in to the Pythagorean theorem to solve for X. So what would that give me? That would give me leg squared. What leg? One of the legs? 3. So first we're going to write it out. 3 squared plus, what's the other leg? 4. So 4 squared is equal to the hypotenuse squared, but we don't know what the hypotenuse is yet, so we're just going to write X squared. Okay. So far so good? We just plugged it all in. Okay, let's keep going a little bit. What is 3 squared? 9 plus 16 is equal to X squared. We still don't know what X is yet. Okay, so what is 9 plus 16 give me? So 25 equals X squared. Okay, now we have to solve for X. Let's think about this. Back at the very beginning of the year when we were solving for X, if I had a problem that looked like X plus 3 equals 5, what would I do to solve for X there? Right, we would subtract 3 from both sides. Why are we subtracting 3? Because it's the opposite of adding 3, right? They cancel each other out. So then this would give me X equals 2, right? The idea here is exactly the same. The operation is just different. I have X squared. Now I haven't solved for X yet, right? I don't have X all by itself. It has the squared attached to it. Can anybody think of what is the opposite of squaring something? Well, is squaring the same as multiplying? Matthew, will you say a little bit louder? The opposite of squaring something is taking the square root of it, right? So if we take the square root of both sides, taking the square root of X squared They cancel each other out, that square root and that squared. So what is the square root of 25? 5. So we get x equals 5. So if we ever have x squared, we want to get rid of that squared term because we need x all by itself. X equals something. So the opposite of taking the square of something is taking the square root. It's like multiplication and division are opposites. Addition and subtraction are opposites. Square and square root are opposites. Okay? Let's check our answer just really quick. So let's plug everything back in and see what we get. We had, I'm going to write check right here. We had 3 squared plus 4 squared equals, what did we find out x was? 5. So it would be equals 5 squared, right? 3 squared was 9 plus 4 squared was 16 equals 5 squared, which is 25. 9 plus 16 is 25, so 25 equals 25. Is that true? Yes, so it was the right answer. Let's try another one. Okay. Example 2. Okay, can someone name one of the legs for me? 15, thank you, Anthony. And what's the other one, Emily? 8 is the other one. What is the hypotenuse here, guys? X. We don't know what it is yet. So let's plug it in, everything, into the Pythagorean theorem. So that would give me 15 squared plus, what's the other leg? 8 squared is equal to what? X squared, right? Okay. What is 15 squared? Not 30. It's not 15 times 2. It's 15 times 15, which gives me 289? 225. So 225 plus 8 squared is 64. Equal to, we still don't know what x is, so x squared, right? Okay, what is 225 plus 64? 289. Okay, is equal to x squared. Okay, now, is x by itself yet? No, it's x squared still, right? How do I get rid of that square? Take the square root. Okay, now that square root and that squared are going to cancel each other out because they're opposites. So we would get x equals, what is the square root of 289? Does anybody know? Good, 17. Okay, how do we know? 17 times 17 gives me 289. And it's on the chart up there, yeah. Okay. Okay, example 3. Who can name one of the legs for me? Matthew. 10? Wrong. What? Julian. X is a leg. And what's the other one? Good, 6. Why is 10 not a leg? Because it's a cross from that 90-degree angle, so that means 10 is actually our what? Our hypotenuse. Good. Okay, so this time I know one leg and the hypotenuse, and I need to find the missing leg. Do you think we can still do it? We can. What is the Pythagorean theorem? Leg squared plus leg squared equals hypotenuse squared. So one leg is x, so x squared plus 6 squared is equal to, very good, is equal to 10 squared. So this time the variable is just in a different place, but we still plugged everything into the Pythagorean theorem. Okay, we don't know what x squared is yet, right? So we're just going to leave it as x squared plus, what is 6 squared?
36.
Good, 36 is equal to 10 squared? 100. Okay, now what do I have to do? Good, we need to get x by itself, which means I have to first subtract 36 from both sides, because we have a plus 36 added on there. So that's going to give me x squared is equal to 100 minus 36. 64. Okay, so I'm done, right?
Nope.
No, what do I have to do? Take the square root. Square root and the squared term cancel each other out. So we are left with x equals, what is the square root of 64? 8. Good job. 8 times 8 gives me 64. So the missing leg is 8.